let's talk about some of the common issues that new programmers have when using C that you don't usually see in other kinds of languages like Python and MATLAB. So first we'll talk about rollover. Let's consider that we have an unsigned int. So that means it's let's do a char. Make this a little faster to write. So a char is an 8-bit variable. Unsigned means that it will start at 0 and go to 255. So let's say I took 60 plus 80 and stored that into my char. Well, that's 140. That fits fine. But let's say I did 60 plus 200. Well, that's going to be 260, but that's bigger than the maximum value that we can store in an 8-bit unsigned number. So what is happening here? The number 60 in binary is, we'll start that with the 0b to remember that this is a binary number. 0, 0, 1, 1, 1, 1, 0, 0. And the number 200 is 1, 1, 0, 0, 1, 0, 0, 0. So when we add those, we're going to get 0, 0, 1. 1 and 1 is a 0, we carry a 1. 1 and 1 is a 0, we carry a 1. So we end up with a 9-bit number. Now when we tell C to do this instruction, it's going to throw away the 9th bit because it can't be stored into an unsigned char. So this ends up being the number 4. Okay, the next common thing we'll see is integer-based math. So I will make an int I. So integers are whole numbers. And if I said I equals 2 divided by 3, well, of course, we're going to get 0, right? Because that's a 0.6, and 0.6 is not a whole number. So it's not even rounding. It's just going to throw anything away that's after the decimal point. So instead, I probably wanted to do float. F equals 2 divided by 3, right? Because float is a floating point number. It will keep the decimal. But what happens? We're not being very explicit about this kind of math. 2 is an integer and 3 is an integer, so the compiler might decide, oh, I should do integer-based math. And integer-based math here is faster than floating point math, so I'll save some time. I get 0. Or maybe I should be more explicit and say 2.0 divided by 3, and now I'll get my 0.66. So this kind of implicit and explicit declaration, we'll talk about that more in a little bit. The last common thing that we see in C is just how to deal with arrays. So let me just declare an array int x, which has 4 values. And here's how you can hard code values. You can just say curly brace and then the values that you want. I have 4 values, so the size of x is 4. Now I can ask for what is x of 1. That's pretty easy. We start our indices at 0, so x of 1 is 3. I could ask for what is the value at x. Remember that the name x of the array is the pointer to the first element. So if I say star of that pointer, I get the value there. So that is 4. Let's say I asked for star of x plus 2. Well, x points to 4. And the compiler is smart enough to say, let's not advance the address by 2 physical addresses. Let's go forward by 2 ints, because pointers store both the value of the address and it remembers how much the incremental amount would be. So x plus 2 is 2, so star of that value gets us the value there. Okay, we could ask for, say, x of 4. This is pretty common and a good bug. Because if we started at 0, this is x of 3. X of 4 is whatever comes after this array in memory. We don't know what that is. And the compiler's not going to tell us that that was a bad thing to do because it doesn't really know where the end was, and maybe you were trying to do some trick where you took advantage of that. So that's a bug. Try not to let yourself go past the end of your own array. And now let's do a complicated one. Let's do star of ampersand of, say, x of 1. And then we'll add 1. So x of 1 is the value 3. Ampersand of that 3 says let's point to that 3. Add 1 says now we point at 2. Star of something that points to that 2 is 2. Okay, so this expression is pretty made up. You probably won't see that in real life. But floating point math that's done accidentally with integer-based math, that comes up a lot. And accidentally doing math that can't fit into the data type is another kind of bug. So watch out for those.